we're going to use base 10 as our default base. This is not to say that there aren't certain cultures that use other bases or that you can't use different bases when talking about different things. The reason that we use base 10, in fact, is really just so that we can communicate with other people. If you remember, that's the point of using numbers at all, is to be able to communicate a quantity to other people. You can imagine that if we are using base 10, this would mean 1 10 and 0 1s. But if someone else was using base 8, this exact same symbol, 1 and then 0, would to them mean 1 8 and 0 1s. This is why it's important that everyone uses the same base, which is why we've decided to use base 10. We think that the reason that most groups have started to use base 10 and that it's sort of become the norm for the world is because we have 10 fingers and 10 toes. And an easy way to count is by using your fingers and toes to represent. You can see that if you were trying to represent to someone else, maybe very early on before we've invented this, how many of something. If you needed to use 3, you might be able to just gesture 3 with your fingers. So we think that that's where base 10 comes from. This idea of using the same system as everyone else, not necessarily for a concrete reason or because it's better than other systems, is called using something by convention. It's the same reason that we use the symbols we do to represent numbers. So instead of representing 1 maybe this way, and 2 this way, and 3 that way, or something, we use what we call the Arabic number system, which, by the way, looks like this. You can see that by using base 10 with our compact number system, you can represent any number. Even if it's a number we haven't thought of before, we can think of how to represent it, because we can think how many 10s are there, and then how many 1s are there. Similarly, say we have 7 10s and 1 1. What if we want to think of something with 10 10s? Wouldn't it make sense then to just write that over here as another 1? So you can see how we can represent really, really, really large numbers by writing the symbols next to each other. So this represents 5 1s. This represents the number of 10s. This represents the number of 10 10s, so the number of hundreds, the number of thousands, the number of 10,000s, and so on and so forth. You can see that if you're still using tick marks, it would be virtually impossible to represent this number. It might take a year to write it. You can see that with this number system, the problem of there always being one more number is not a problem anymore. If, for example, you write any of these numbers from 0 through 8 in one of the places, which is to say one of the places that represents the number of 1s or the number of 10s or the number of hundreds, etc., and then you have one more number, or one more set of 10, or one more set of 100, you can just increment whatever number you have to the next one. The only problem is if you have 9. Then if you have one more than that of whatever place that you're talking about, you have to make it 0 and then add 1 to the next place. You can see that eventually, no matter what number you're adding it to, there will either be another place that isn't 9, so you stop having to add 1, or you'll reach the end of a number. So if I'm trying to add 1, sorry, that's kind of small. If I'm trying to add 1 to 999, yes, it might be kind of annoying because here I have to make this into 0 and then add 1 here, and then make this into 0 and then add 1 here, and then make this into 0, but eventually I reach the end of the number and I can just add another 1 there. So no matter what number you have, it's possible to represent a number that's 1 bigger than it. To go over that more slowly, if I add 1 to 9 1s, that makes it 110. So that's why we now make this 0 1s, because there are no 1s that aren't a 10 anymore. And we add another 10, but now there are 10 10s, So now there are no tens that aren't part of that group. Then that means we have to add 1 to this, because now the 10 tens became 100, but now we have 10 hundreds also. So we still have to write another 0. But now that we have 10 hundreds, we know that we can add a 1 to the 10 hundreds place. And since we've reached the end, we can just add another 1. Additionally, if you had something like 5,999, you would still, and you wanted to add 1 to it, you would still have to go through and write, okay, so we have 0 ones because we have to move 1 over to the tens. Then we have 0 tens because we developed 10 tens, which become 100. Then we have 0 hundreds because we've developed 1,000. But you can just write 6,000 and just increment 1 more because you've added 1 to it. So with this number system, it is a way to represent every conceivable number, and the only symbols you have to memorize are these 10 right here. You can see that even if there's a number that you've never thought of, that no one else has ever thought of, you have an easy way of representing it. And it might take a long time to write if there are a lot of tens in it, and maybe lots of hundreds and a lot of thousands, but you will reliably be able to represent it without having to write 1 for every single one in the number, or without having to memorize an infinitely large number of randomly chosen symbols.